Hello everyone! I am Teacher Janelle.
And I'm Teacher Rhea.
And today, we will learn about a new lesson.
And this is all about the sun.
So guys, fasten your seatbelts.
Focus and listen very carefully
as we travel around the sun.
The sun.
You know what guys? The sun is a star at the center of the solar system. It is almost perfectly spherical and consists of hot plasma interwoven with magnetic fields. It has a diameter of about 1,392,684 kilometers, about 109 times that of Earth. And its mass accounts for about 99.86% of the total mass of the solar system. Chemically, about the 3/4 of the sun mass consists of hydrogen, while the rest is mostly helium. The remainder, 1.69%, which nonetheless equals 5,628 times the mass of Earth, consists of heavier elements, including oxygen, carbon, neon, and iron, among others.
The sun formed about 4.6 billion years ago from the gravitational collapse of a region within a large molecular cloud. Most of the matter gathered in the center, while the rest flattened into an orbiting disk that would become the solar system. The central mass became increasingly hot and dense, eventually initiating thermonuclear fusion in its core. It is thought that almost all other stars form by this process. The sun's stellar classification, based on spectral class, is G2V and is informally designated as a yellow dwarf because its visible radiation is most intense in the yellow-green portion of the spectrum, and although its color is white, from the surface of the Earth it may appear yellow because of atmospheric scattering of blue light. In the spectral class label, G2 indicates its surface temperature of approximately 5,778 Kelvin or 5,505 degrees Celsius. And V indicates that the sun, like most stars, is a main sequence star and thus generates its energy by nuclear fusion of hydrogen nuclei into helium. In its core, the sun fuses 620 million metric tons of hydrogen each second.
Under the internal structure, we have inner core and photosphere, or convection zone. Inner core. The weight of the Sun's outer layer compresses the gas of the innermost region to a density about 100 times that of water and raises the central temperature to about 15 million Kelvin or 27 million degrees Fahrenheit.
Convection zone and the photosphere. Near the Sun's visible surface, as the weight of overlaying gas diminishes, the gas pressure and thus the density and temperature required to support this layer in hydrostatic equilibrium decrease rapidly. Convection continues to be efficient in transporting heat until layers are reached where the density is so low that radiation from the hot upflowing gas can escape directly into the space. This layer is the visible surface of the Sun known as the photosphere.
The atmospheric structure of the Sun composed of chromosphere and the corona. Chromosphere. Above the photosphere, the temperature drops to a minimum of 4,500 Kelvin and then, remarkably enough, begins to rise. During a few seconds, around totality during a solar eclipse, a thin ring about 10,000 kilometers thick around the limb is seen shining with a reddish glow, leading to its designation as the chromosphere.
Corona. During a total solar eclipse or with a coronagraph, the Sun's atmosphere can be seen extending to several solar radii beyond the photospheric limb as a faint glow, about 1 million times less bright than the disk. The reason that the corona extends to such heights is that it exists at temperatures of several million Kelvin. Because a hot gas is compressed relatively less by the weight of overlying layers than a cool one, the corona remains visible much farther above the limb than might be expected.